Alright, what's going on, folks? Mr. Brunswold here. I'm in the school right now. So today we're going to be doing part 2 of the Force of Gravity lab. So in the first part of the lab, you should have seen that when we found the relationship between the mass of those different weights and the amount of force that they put on the spring scale, when we graphed them and found the best fit line, that slope had a certain value. Today what we're going to be doing is comparing that to the slope when we drop an object and measure its acceleration as it falls toward the ground. What we have here, this is a Vernier Photogate. Basically, it's got two little light sensors in between here that it uses to detect when an object is falling through it. So I don't know if you can see, there's a little light on this end, and so when I put my hand in between the sensor, lights up, so that lets it know that it's detecting something falling in between. And so then what I have here is a little plexiglass object, and it's got black lines marked at even intervals throughout the object. So what's going to happen is when I drop it and it starts to go through the sensor, actually here I'll show it on this end so you can see the light. When I drop it and it starts to go through the sensor, it'll light up as each part goes through the sensor. And so then the sensor is hooked up to my computer, and so then the computer is going to take data on the position and when it sees when it sees one of the black lines go through the sensor, and then also the time, right? For when I start recording data, at what time does the object fall through the sensor? So I'm going to drop it, and then when I drop it through, the computer's going to collect data, and I'll show you that in just a second here. And then we're going to analyze that data and see how it compares to the first part of this lab. So let's take a look here. So here I'm going to set it up, and then I'm going to drop it. Oh, whoops, didn't quite have it held up high enough. Let's try that one more time. So now I'm going to hold it up here, and then I'm going to drop it. Okay. And so then up next I'm going to show you what the data looked like as I dropped that through. So here's a plot of the data as I dropped that object through the sensor, through the photogate. And so we can see this is the distance. Those are spaced at 0.5 meter intervals, because that's 0.05 meter intervals, because that's how far apart the lines are spaced on that picket fence. So each black line is 0.05 meters or 5 centimeters apart. Okay, but you can see the times are not evenly spaced, right? So from the first point to the second point, the time is shorter than from the second point to the third point, and from the third point to the fourth point to the fifth point, so on and so forth. Okay, and so we can do a curve fit to that. Apply curve fit, and this one should be quadratic, and you can see that fits really well, right, because this object is accelerating. But if we want to get the acceleration, we need to look not at the distance versus time, but the velocity versus time, because remember that acceleration is the change in velocity. So what we're going to do is we're going to add a second curve. Okay, we're going to put velocity on this axis, and we're going to add a curve fit. That one's going to be linear, and you can see that linear curve fit pretty much goes through all the data points. And we can see that the slope for this works out to be 9.572. Well, this slope should be extremely similar to the slope that you got in the first part of our lab. And the reason why that is because the rate at which objects fall on Earth is always the same. And that's because the acceleration that's caused by the Earth's gravity is always the same for objects. It doesn't really matter how heavy they are, which is maybe a little bit of a surprise to you, right? You might think that lighter objects don't fall as quick as heavier objects do. That's not the case, as we're going to see in our next video here. But what this shows, though, what this experiment and what the first part of the force of gravity lab shows is that objects on Earth always have the exact same acceleration. It's 9.8 approximately, right? It didn't work out to be exactly 9.8 in this lab, but pretty close to.